Mr. Arun, working as Head of Department Civil, Government Polytechnic Badbar. The name of this polytechnic is Sant Baba Atar Singh Government Polytechnic Badbar, which is located on the road of Sangrur to Barnala. Respected teachers and dear students, today I will discuss with you a topic regarding the measurement of pressure, which is in the subject of fluid mechanics, which is in the third sem civil. The various contents of this measurement of pressure which we will deal. First, certain technical terms related to fluid mechanics, atmospheric, absolute, vacuum, gauge, pressures. Means atmospheric pressure, absolute pressure, vacuum pressure and the gauge pressures. Then we will discuss the manometers, simple manometers, differential manometers. Then we will discuss the mechanical gauges. The mechanical gauges are of three types: Bourdon tube pressure gauge, diaphragm pressure gauge and dead weight pressure gauge. First of all, the definitions from comes the density, means mass density. So, mass density means the density of a fluid may be defined as the ratio of mass of a fluid per unit volume. It is denoted by the symbol rho. The rho is just like a very simple form of P. So, mathematically the mass density, it comes the mass of the fluid per volume of the fluid. The units of density in SI units is kg per meter cube. The density of water at 4 degree centigrade at the standard conditions at the mean sea level is 1000 kg per meter cube. So, density means the density of a fluid is the ratio of the mass of the fluid per unit volume, and the units are kg per meter cube, and of standard water at 4 degree centigrade at the mean level is 1000 kg per meter cube. Then come the next definition of weight density. The weight density of a fluid is defined as the ratio of weight of a fluid per unit volume. It is called the specific weight and is denoted by small w. So, mathematically we can say the weight density is the weight of the fluid per volume of the fluid. The units of the weight density. The units of the weight density in SI units are weight in Newton and volume in meter cube. So, its units become in SI units are Newton per meter cube, and the specific weight of water at 4 degree centigrade at the mean sea level is 9810 Newton per meter cube. So, weight density means, so weight density is the weight of the fluid divided by the volume of the fluid. So, its units in SI units are newtons per meter cube, and its value comes out to be 9810 Newton per meter cube. Then we come the specific gravity. The specific gravity is defined as the ratio. Specific gravity is defined as the ratio of the specific weight of a fluid to the specific weight of a standard fluid. So, specific means it has got the ratio of the two. One is from the specific weight of a liquid who we want to find divided by the specific weight of a standard fluid. For the liquids, standard fluid in water at 4 degree centigrade. For the gases, the standard fluid is taken as air at 0 degree centigrade. Because it is the ratio of the two units, the units of the specific gravity means specific gravity is a dimensionless, because it is the ratio of the same two units. Same two units means specific weight of a liquid divided by specific weight of the standard fluid. For liquids, the standard fluid is water at 4 degrees centigrade, and for gases, the standard fluid is taken as air at 0 degree centigrade. So, it has got no unit. The specific gravity has got no unit because it is the ratio of the two specific weights, specific weight of liquid to the specific weight of fluid. And for the liquid, the standard fluid is water at 4 degrees centigrade, and for gases, the standard fluid is air at 0 degree centigrade. It has got no unit. It has got no unit, that is specific gravity. Then we come to the pressure. So, pressure means force exerted by fluid per unit area. So, pressure means force exerted by fluid per unit area is known as pressure or intensity of pressure. So, means that pressure means intensity of pressure is the ratio of pressure divided by area. So, the intensity of pressure is represented by small p, and the units of this we come to say P, where capital P is the force in newtons and the area which we will calculate the area in meter square. So, the units of the pressure, or we can say pressure intensity, is Newton per meter square. So, this is also known as pascals. So, Pascal means Newton per meter square, and it is represented by capital P in the small a. So, Pascal means PA. PA means Newton per meter square. So, this is for pressure. So, pressure means force exerted by fluid per unit area is called pressure, or it is also known as intensity of pressure. So, intensity of pressure, or we say pressure, is the ratio of the P divided by capital A. So, small p means intensity of pressure is the ratio of pressure P divided by capital area, where P is the force in newtons and the area जो है is comes out to be in meter square. So, the ratio of intensity of pressure means P divided by capital A. So, P means in terms of newtons and the area in terms of meter square. So, the units of pressures are Newton per meter square. So, the Newton per meter square means the units we say it as Pascal. Pascal means PA, unit of pressure or the intensity of pressure. So, we will now discuss the atmospheric pressure. So, atmospheric pressure means it is the normal pressure. It is the normal pressure exerted by atmospheric air upon all the surfaces with which it is in contact, It is also called as a barometric pressure also. It is also called as barometric pressure. It is measured by barometer because it is measured by an instrument which is known as a barometer. So, barometer is an instrument which registers the height of column of any liquid. The atmospheric pressure at the sea level is called as standard atmospheric pressure. So, once again I say the atmospheric pressure at the sea level is called standard atmospheric pressure. So, once again we say atmospheric pressure is the normal pressure exerted by atmospheric air upon all the surfaces with which it is in contact. It is called barometric pressure. So, barometric means it because it is measured by barometer. So, barometer means an instrument which registers the height of the column of any liquid. So, atmospheric pressure at the sea level is called standard atmospheric pressure. So, atmospheric pressure is measured by barometer and the instrument which registers the height of column of any liquid. the equivalent value of atmospheric pressure at sea level upon normal conditions are 1,13,000 Newton per meter square, or it is equal to 1.013 bar. Secondly, 10.34 meter of water, or it is 760 millimeter of mercury. So, once we say atmospheric pressure is measured by barometer and instrument which register the height of column of any liquid. Next we come gauge pressure and vacuum pressure. The atmospheric we say as gauge pressure and vacuum pressure. The pressure which is more than atmospheric pressure is known as gauge pressure, or it is known as a positive pressure, keeping atmospheric pressure as a datum value. The pressure which is less than the atmospheric pressure is known as vacuum pressure, or it is known as a negative pressure, or it is a suction pressure. So, means that there are two types of the pressure. So, with respect to the atmospheric pressure, so the absolute pressure is defined as pressure measured above absolute zero pressure, and absolute zero pressure can exist in complete vacuum. Mathematically we can say absolute pressure, which is P1, is equal to the atmospheric pressure plus the gauge pressure. So, gauge pressure is a positive pressure. So, the absolute pressure P1 is the atmospheric pressure plus gauge pressure. Secondly, we say absolute pressure P2, which is also equal to atmospheric pressure minus the vacuum pressure. Vacuum pressure means negative pressure. Now, from this it is clear. So, this is the atmospheric pressure and this is a gauge pressure. So, if we make this barometric measurement of the atmospheric pressure, now this measurement of this barometric pressure plus the gauge pressure, so this atmospheric pressure plus the gauge pressure, so this comes the absolute pressure P1. So, absolute pressure is atmospheric pressure, which is barometric pressure plus the gauge pressure. Now, secondly we say vacuum, that is negative. So, the atmospheric pressure, which is barometric pressure minus the vacuum, becomes the absolute pressure in case of the negative, that is P2. So, P1 means the absolute pressure. So, absolute pressure means the barometric pressure plus the gauge pressure, which is known as a positive pressure. Secondly, we say as P2. P2 means the barometric pressure minus the vacuum pressure. So, this out of this we subtract the negative pressure and we find out the P2. P2 means, so this is the absolute pressure which is below the atmospheric pressure. So, next we come to the measurement of the pressure. So, pressure of a fluid is measured by following devices. जो pressure हमारे पास है उसको हम कैसे मापते हैं? So, the instruments which we are using for measurement of the pressure is the manometer, and secondly we say as the mechanical gauges. So, the pressure of a fluid is measured by following devices. First we say as manometer. So, these are the devices which are used to measure the pressure at a point in a fluid. Secondly, mechanical gauges. These are the devices which are used to measure the high fluid pressure where tube gauge cannot be conveniently used. Then we come to manometers. So, manometers are defined as the devices used to measure the pressure at a point in a fluid. These are also used to measure the difference in pressure between 2 points in a pipe or in two different pipes. Manometers are based on the principle of balancing the column of fluid by the same or an other column of fluid. Then we come to the classification of manometers. So the manometers are classified as simple manometers and secondly the differential manometer. So simple manometers are further of types. First we say as the piezometer, then secondly U-tube manometers, thirdly single column manometers. So the differential manometers are of further types. Number one, U-tube differential meter. The second one is inverted U-type differential manometer. So we say as the manometers are of two types, one is known as the simple manometers and the second one is known as differential manometer. जो सिंपल मैनोमीटर्स हमारे पास हैं वो आगे हमारे पास तीन तरह आएंगे. फर्स्ट वी से एज ए पीजोमीटर, सेकेंडली वी से एज ए यूट्यूब मैनोमीटर एंड थर्ड सिंगल कॉलम मैनोमीटर. जो हमारे पास डिफरेंशियल मैनोमीटर्स हैं वो हमारे पास टू टाइप्स के हैं. वन इज ए U-tube differential manometer and secondly as the inverted U-tube differential manometers. So first we say simple manometer. So simple manometer measure the pressure at a point of a fluid in a pipe or in a container. So simple manometer जो है वो हमारे पाइप के अंदर या कंटेनर के उनके साथ लगा देते हैं और उसका जो सिंपल प्रेशर जो है मेजर करने के लिए यूज़ करते हैं. दैट इज नोन एज ए सिंपल मैनोमीटर. what is it is made of? It consists of a glass tube, one end of which is connected to a point at which the pressure is to be measured and other end is open to atmosphere. Now first we say as piezometer. So let us see the piezometer. So first we say as piezometer. It is the simplest form of manometer and is used to measure the moderate gauge pressure. So it is a simple form of manometer which is used to measure the moderate gauge pressure. One end of the glass tube is connected to the point where pressure is to be measured and the other end is open to atmosphere. Now let us see. So this is the device for which we want to find the. So here we are getting to connect this piezometer, this at this one, and we get the other end is bilkul free. So this head which is measured, that is known as the measurement of the pressure. So it is a simple form of manometer and is used to measure the moderate gauge pressure. One end of the glass tube is connected to the point where pressure is to be measured and the other end is open to it. So this is for which we are getting to measure with the help of piezometer. One end is connected and the other end is free. So this is a very simple type which we say it as a piezometer. It cannot be used to measure the negative pressure or measurement of pressure for the gases. इसके अंदर एक ड्रॉबैक है कि हम नेगेटिव प्रेशर और द प्रेशर ऑफ गैसेस जो है वो इसके साथ नहीं मेजर कर सकते. सो प्रेशर एट ए पॉइंट, सो दिस इंटेंसिटी ऑफ प्रेशर P is equal to W into H. So next we come U-tube manometer. So this is a U-tube manometer. So this is a U-tube manometer because it is form of a U. The tube is in the form of a U, and for this it is a fluid. Here this is a fluid of fluid density which we want to measure. Now what is it? Consists of a glass tube bent in the form of U shape. So this is a U shape. Now we say this is a U shaped tube. One end of this tube is connected to the point at which the pressure is to be measured and the other end remains open at this. So let us see. this U tube is connected here and the other end is free. The tube generally contains a liquid called manometric liquid having the specific gravity greater than the liquid whose pressure is to be measured. Then single column manometer. So, this is a single column manometer. So, this is a vertical single column manometer. Now, let us say what is this? It is used for measuring small pressure where the accuracy is of much importance. It is a modified form of U tube manometer. So, U tube manometer say it is certain modified form. A reservoir is connected to one of the limb. The cross section area of the reservoir is much larger than that of the other limb. So, the pressure at A, so this is at A, so the pressure at A, HA is equal to delta H, this delta H, the difference ब्रैकेट के अंदर S2 माइनस S1 प्लस H2 into S2 minus H1 in S1. So, this HA is equal to delta H ब्रैकेट के अंदर S2 minus S1 plus H2 into S2 minus H1 in S1. Then comes the differential manometers. So, this is a differential manometer. This is a differential manometer. Here it is fresh water and this is the sea water. So, this is the air and here it comes a mercury. Here it comes the mercury. So, differential manometers are the devices used to measure the difference of pressure between the 2 points in a pipe or in the 2 different pipes. So, एक पाइप के अंदर 2 पल्सेस लगाते हैं और 2 के अंदर हम भी इसको लगा सकते हैं. It consists of U tube made up of glass. The 2 ends of the U tube are connected to the 2 points where difference of pressure is to be measured. So, differential manometer, there are 2 common types of the differential manometers, U tube and inverted U tube differential meter. So, U tube differential manometer, the first case is U tube differential manometers. So, this is a U tube which is connected to the 2 ends, one A and the other B. We say the figure shows the differential manometer whose 2 ends are connected with the 2 different points at A and B at the same level and contain the same or different liquid. So, this A and B, this is A and B at which we are getting to connect this U type of the differential manometer. They may be of the same liquid or they may be of the different liquids. So, the difference in pressure head at A and B. So, this is HA minus HB. So, difference of head of between the point A and B. So, this comes out to be the difference. So, here and this difference. So, this is equal to H multiplied by S minus S2 where S1 is equal to S2. So, U tube differential manometers head A minus head at B is equal to H bracket के अंदर S minus S2. So, HA is the pressure head at A in terms of head of water. HB is the pressure head at B in terms of the head of water, where H is the difference of levels of the heavy liquid in the U tube. HA means it is the pressure head at A in terms of the head of the water. HB is the pressure head at B in terms of the head of the water, and H is the difference of levels of the heavy liquid in the U tube, and S is the specific gravity of the heavy liquid, where S2 is the specific gravity of liquid in the pipe B. So HA minus HB is equal to H bracket के अंदर S minus S2. Then comes the U-tube differential manometer. It is a second type. So the figure show the differential manometer whose two ends are connected with the two different points A and B at the different levels. So here it is for A, here it is for B, because A and B, they are at the different levels. Earlier we have seen that they were at the same level. Earlier we have seen that they were at the same level. This is at the level A and B, but now we find that they are at the different level. This is A and B, they are at the different level. So that is why it is differential manometer, because it is of a U shape, it is known as U-tube differential manometer. It is a second type. The figure shows a differential manometer whose two ends are connected with two different points at A and at B. These are the two levels at the point A and B, which are at the different levels. Here it is level A and here it is level B. So the difference in pressure head at A and B is given here. This is the equation. This is the head A minus head B, which is equal to S1 ब्रैकेट के अंदर जो हमारे पास H2 minus this H1. So this is H2 minus H1 and this is the head H. So this is for the specific gravity as for the liquid which we are getting to utilize here. Then we come to inverted U-tube differential manometer. This is an inverted type. So this is a, here we say the tube is an inverted. This is one and inverted. Here are the two points A and B having the liquid A, this is having liquid B, this is has got the specific gravity S1 and this is for S2. So it is used to measure the difference of low pressure where the accuracy is the major consideration. It consists of an inverted U-tube containing light liquid. The two ends of this U-tube are connected to the 2 points whose difference of pressure is to be measured. Then we come inverted U-tube manometer, inverted differential. Earlier we have seen that they were at the same level, but now these are the two at the different levels. Here are the point A, this is for point B, having a liquid of specific gravity S1, having the specific gravity S2, they are at the different level. Let us see that this is the difference of level. Here it is providing H1 head, this is providing head H2, and this is the difference of the head, and this is a inverted U-tube. So it is containing the certain material and the pressure difference is this H1. So inverted U differential manometer, it considering the pressure at A is more than the pressure at the point B, and the difference in pressure head at A and B is given by this equation. This is head A minus head B is equal to, so इसका और इसका जो head है हमारे पास उसको multiply करते हैं. Let us say H1 minus H1. This is H1 head H1 liquid of specific gravity S1. Difference between two, this is H2 into S2. This is for H2 having a specific gravity S2. So इसमें इसका जो है प्रोडक्ट इसमें निकाल के और जो हमारे पास जो लिक्विड है इसका स्पेसिफिक ग्रेविटी विद दिस हेड. सो दिस इज H into S. So in the inverted U differential manometer, HA minus HB comes out to be H1 S1 minus H2 S2 minus HS. Then we come to the advantages of manometer. Good accuracy and high sensitivity, relatively inexpensive and easy to fabricate, suitable for low pressure. Fourth one, sensitivity can be easily changed by changing the quantity of the manometric liquid in the manometer. It requires a little maintenance. So limitations of manometer, इसके अंदर जो ड्रॉबैक्स हमारे पास है, सो ड्रॉबैक्स जो है हमारे पास वो कौन कौन सी हैं? रीडिंग ऑफ मैनोमीटर्स आर अफेक्टेड बाय चेंजेस इन ग्रेविटी, सेकेंडली एटमॉस्फेयर, थर्डली बाय एल्टीट्यूड. सो जब भी हम इसकी पोजीशन चेंज करते हैं वन प्लेस टू अनदर प्लेस, द ग्रेविटी इज चेंजिंग,